Welcome dear students. This lecture is about the types of the different chemical reactions. We will divide this topic into two lectures. This is the lecture 1 in which we are going to discuss the reactions among the similar atoms and molecules. The first type is the association in which the same molecules they join together to form the large aggregates. The chemical composition remains same, but the aggregation of the same molecules takes place due to the intermolecular forces. Just like a large number of the water molecules, they join through hydrogen bonding and they form the aggregates of the water molecules. This aggregation is responsible for the liquid state of the water, while in case of H2S, as the molecules they do not aggregate, that is why the H2S exists in the gaseous state. So that was the first type, and it is association. The second type are the dissociation reactions in which the degradation of a chemical substance takes place. Now the dissociation may be thermal, in which a molecule is broken down by heating, or it may be ionic, in which some ionic compound is dissolved in the polar solvent and it is ionized to the cations and anions. One of the examples of the thermal decomposition is the heating of ammonium chloride. It will degrade to form ammonia and HCl molecule. And my dear students, on cooling, again ammonia and HCl, they will combine to form NH4Cl, ammonium chloride. So this is basically a reversible reaction in which a molecule breaks down into two or more molecules on heating, and then these two dissociated products they rejoin on cooling to form the original substance. And because it is reversible, it means the substance which is dissociated and the products of the dissociation they will be present at dynamic equilibrium with each other. The second one is ionic dissociation, in which an ionic compound that is dissolved in the polar solvent and it is dissociated into cations and anions. But my dear students, on drying or removing the solvent, the cation and anions they again combine to form the solid crystals of the ionic compound. So it is also a reversible reaction. The next one is decomposition. In decomposition reaction, a single substance is broken down into two or more different types of the molecules. My dear students, the dissociation is reversible, but the decomposition is irreversible process. Just like the potassium chlorate, when heated, it is decomposed into potassium chloride and oxygen. And similarly, the lead nitrate on heating, it is decomposed to form lead oxide, nitrogen dioxide and oxygen. But dear students, these molecules on cooling, they do not react to form the original substance again. So that is the major difference between the dissociation and decomposition, that dissociation is a reversible phenomena while the decomposition that is irreversible. The dissociated products they do not on cooling join to form the original substance. Similarly, the next is the disproportionation reaction. These are the reactions in which a single compound is oxidized as well as reduced due to the variable valency of the metal present in it. Just like in case of this cuprous chloride, my dear students, the oxidation state of copper is +1. But when it will be changed to cupric chloride, its oxidation state will be +2, and in free state oxidation state is 0. So when it is changed from +1 to +2, it gets oxidized, and when it is changed from +1 to 0, as the oxidation state is decreasing, so it is being reduced. So a single substance gets oxidized as well as the reduced, and in this case this cuprous chloride is getting oxidized as well as reduced due to the variable valency of the copper. Similarly, in case of this gold chloride, the oxidation state of gold is +1 and it is changed to AuCl3. In this case, it is +3 and in free state it will be 0. Now, my dear student, again, when the gold changes from +1 to +3, its oxidation state is increasing. So we will say that it is being oxidized. But when this gold changes from +1 to 0, its oxidation state is decreasing. So in this case, the gold is reduced. Again, a single species that is getting oxidized as well as the reduced due to the variation in its valency. So that will also be an example of the disproportionation reaction. Basically, it is a subtype of the redox reactions. But in redox reactions, there are two different molecules. One is oxidized, other is reduced. But in disproportionation, it is also called as the self-oxidation reduction reaction. So in self-oxidation reduction or disproportionation reaction, there is a single compound oxidized as well as the reduced. The next is condensation. My dear students, in case of condensation, two small molecules, they join to form a large molecule with the elimination of a small molecule. Just like in this case, these are the two molecules of the sulfuric acid. They will join, and when they will join, water will be released, and after the loss of water, they will join to form the pyrosulfuric acid, which is also called as oleum. So condensation reactions are basically addition elimination reactions in which the two substances they join to form a large compound with the elimination of a small molecule. In most of the condensation reactions, a small molecule as a byproduct is removed. The next one is the polymerization. Polymerization is basically the joining of the very large number of the molecules, and that number should be greater than 2. When three or thousands of the small molecules they join to form an entirely different molecule, then that is called as the polymerization. The molecules that join together, they are called as the monomers, and after polymerization, the product obtained is called as the polymer. Just like in this example, you can see this is the ethene, which is monomer, and when large number of the ethene units they join, they form the polythene. And ethene and polythene, they are entirely different from each other. Obviously, this reaction does not take place at the room conditions. Some specific pressure, temperature, and catalyst is used. Next is the depolymerization reaction. In case of depolymerization reaction, a polymer is broken down into its monomers, and this process of the depolymerization is very important in the recycling of the plastic, in which the plastic is again changed to its monomers, and then the monomers are rejoined to form a new form of the plastic. So polymerization, and there is another type, that is depolymerization. The next one is the isomeric arrangement, in which a molecule is simply changed to its isomer by the rearrangement of the atoms. A very famous example is the heating of the ammonium cyanide, and on heating that is changed to the urea. Ammonium cyanide and urea both are having different physical and chemical properties, but basically with the same type of the elements and same number of the atoms. So one compound is changed to the other. Now ammonium cyanide has the cyanide functional group, and urea is basically an amide. So they are functional group isomers of each other. They have equal number of atoms. They have same number of same types of the elements, but one isomer by the rearrangement of the atoms or units that is changed to another isomer. So that is called as the isomeric rearrangement reactions. My dear students, in all these types, you can see that the reactants and products, they have same types of the elements, or you can say same number of the atoms, same types of the elements. So these are the reactions among similar atoms and the molecules. Next time we will come up with those reactions in which different types of the atoms and molecules they are involved, and that will be lecture 2, part 2 of this topic. Inshallah, we will come up with that next time. Till then, take care.